Hi everyone, Engineer Liu here. So in this tutorial I would like to talk more about the increment operator, the post and pre-increment operator. On the last video when we talked about the while loops and while loops, we use the post-increment operator as seen here, and I would like to highlight the difference between the different operators as in the same example, but as you can see on the first one here we have the pre-increment operator, and on the second example we have the post-increment operator, and we will see how they behave differently and why. Okay, and also we look at some assembly code to highlight what's going on between the scenes. Okay, behind the curtains, let's say. So let's execute I already compiled it, so I will execute the pre-increment .o, and here I will execute, which will be our example 11 underscore post.o. As you can see here, on the pre-increment operator we obtain 1, and on the post-increment operator, as seen on our last example in the last video, we obtain 0. So why does that happen? Well, let's look at the code. Okay, so here in the pre-increment operator, actually before we print anything on the screen, as in both examples, a variable num was initialized at 0. So here we increment and then print on the screen, and then we will print 1 as it was incremented to 1, and it will reach this condition here. It will be greater than 1, and then it will exit the do while loop. Okay, and on the other example where we have the post increment operator, we then print 0, which is the value which was initialized, and then we increment, and it will also then reach the exit condition of this do while loop, and therefore print only 0 on the screen, as you can see here, and this one we only print 1. Okay, so why does that happen? So to understand that a little bit better, we can generate the assembly file by using dash S in our C source code, and it will generate the assembly code. Okay, so we will do this for both the pre-increment and the post-increment. I open then here on Gedit so we can navigate a little bit better between the two files. So don't let this scare you. This is assembly code. It's at first glance it might seem very complicated, but it's not that complicated. So let's take a look first at this LC0. Okay, so basically this is a string. Remember, this is the first argument of our printf function. Okay, it's a text. Its scope is the main function, and here in the post increment we have this as well, which is a string we want to print. And let's switch here. Basically we are initializing our variables. Just take a look at this line here. Okay, move L0 to register RBP. Okay, so basically our register RBP represents our num variable, which is 4 bytes in size. Remember, integer is usually 4 bytes in size. And here as well we move 0 to the register RBP. So this is basically our initialization here. Let me open both files here. Oops. So this is basically this line of code here, but more, let's say more, it's assembly, it's machine code, it's It's actually not machine code, but the closest thing to machine code. So this is actually initializing our non-variable and storing it in the register, in some of the registers in the memory. Okay, both are initialized to 0. And then we can, this is all the initialization of our program. Okay, so then we switch to section L2, and here is where the main loop or do while loop occurs. What the first thing that comes to the mind, comes to the eye, is that in the pre-increment operator we are adding the first operation here on the pre-increment is that we are adding 1 to this register here of 4 bytes. Okay, so this is basically the biggest difference between them. And here we are we don't have this operation here. Okay, so let's check, try to make sense of these operations one by one. And here for the printf function, we have our first argument, which is a format string. Remember, it's LCO, which is stored on the, we are moving to the RDI register. And then the second argument is usually the RSI register, but here we are using, it seems, the ISI register. Okay, so yeah. Okay, so we add 1 to the RBP, and then we move RBP to the main register. The EAX is one of the major of the, could say, the first main register of assembly. And then we move AX to the ASI. Remember, this has 1 here because 1 goes to RBP, RBP goes to AX, AX goes to ASI. And then here we are calling our string LCO, passing it to the RDI register. So these are, I believe, the 2 arguments of our printf function. And then okay, so, and here we are moving 0 to the AX register, and then we call our printf function. Okay, and on the post increment we also move 0 to the AX register, and here we have a jump operation, so this is our, basically our main loop. And here we are comparing if the RBP register is actually is actually 0. Okay, so this is basically the structure of our do while loop. And here we are moving 0 to AX and then performing the syscall to return from the main function. Okay, so this is equal on both programs. Here on the post increment operator, you can see here that we are moving this register ERAX to the EDX register. However, we are not using this to our printf function, because our printf function will utilize the AX register and then copy it to the ASI, and then it will use that as a second argument to the printf function. Okay, despite we having added 1 to, we are preparing this other register here to add 1 to our RBP register. Remember, RBP here is actually our num, so RBP is actually this register here is num, and but we are not calling it to. We are not utilizing this register for printf. It already has one stored in them, but we've copied the register we use in printf before we do the assignment of one. Okay, so this is actually to summarize what is happening between the curtains in assembly code. Okay, so hope you guys like this video. Don't forget to like, subscribe and comment. See you next time, and bye.